Hey, welcome. Today we're going to be talking through how to convert numbers from a binary system to a decimal-based system. And the reason for this is because computers work on a binary system at a very fundamental level. Essentially ones or zeros is how they are represented. And so understanding how to convert back and forth from our base 10 decimal system to a binary system is actually really important for understanding a lot of fundamental technology in computer systems. So before we do that though, we need to take a look at the number 321 and understand a little bit more about our base 10 system and how that works. First of all, one way of writing this out is to say this 1 is like our number 1, that's written right here, times 10, which is the base of our numbering system, to the 0 power is how we're going to think of this. Now, 10 to the 0 power is actually 1, and I prove this at the end of the screencast. I will show you that, I promise, why that is the case, but I'm going to hold off on that until the very end. If we take a look at the second digit here, we've got a 2 times 10 to the first power. So we're going to change this over. 10 to the first power is 10, 2 times 10 is 20, and that is what this 2 in this place represents. And can you anticipate the pattern for what's going to be represented here? Think about what I'm going to show for this third digit right here. Well, what I'm going to show is that we could think of this as being 3 times 10 to the second power. 10 to the second power would be 100, so this would be representing 300. Now the sum of 321 is the entire number, so that would be the sum of these things right here. So let me show our thinking about how we could reason through this. We end up with 3 times 100, 2 times 10, plus 1 times 1, and the sum of those three things is going to be 321. And that's how we write this with a base 10 system. You may not have ever thought of it that way, but think of these 10 digits right here with a base 10 system. These are going to change to a 2 because for a binary system you've only got two options. It's either a 1 or a 0. Let's go ahead and see how to do a binary problem. So this is converting from binary to decimals, and what you're going to do is you're going to start with a binary problem. So I've just made one up right here, 1010, and we're going to start out by thinking about these. So instead of using times 10 to the something power, I'm going to use times 2 to the something power because we only have two options. It's a binary system, meaning a 1 or a 0. So right here, we're going to start from right and move to the left. You could say for this number right here, we've got 0 times 2 to the 0 power. So 0 times 1, effectively. Well, 0 times anything is just 0. So we won't have to worry about this number in a moment. This one over here represents a 1 times 2 to the first power. This one over here represents a 0 times 2 to the second power. This one over here represents a 1 times 2 to the third power. So let's see how this works out in terms of what I've been saying. This is how you could think through this, but just recognize that 0 times anything is 0. So we can get rid of this, and we can get rid of this, and simplify the problem. So what we're left with is 1 times 2 to the third. Well, 1 times anything is just that thing, so we can kind of ignore the 1 here and write 2 to the third, and then we have a 1 times 2 to the 1, which is 2 over here. And just a reminder, 2 to the third would be like taking 2 and multiplying it together 3 times. So that would be 2 times 2, which would be 4 times 2, which would be 8. So 8 plus 2 would be our answer of 10. And that's how you would do your first example problem of converting from binary to decimals. Alright, so let's try a different problem, a little more complex one, but it's the same principle, so let's see how this works. First of all, you're going to think of this as having these numbers above it. So the same pattern as before. Be sure to remember to start with times 2 to the 0 power. It's a common error, I think, when students are learning this to write times 2 to the 1, but you need to write times 2 to the 0 power. Alright, so as long as you can do that, then you just follow the pattern over here and think through what this represents. So I'm going to write my second line here. Remember, this is like saying 1 times 2 to the 0 power. What is 2 to the 0 power? Well, anything to the 0 power is just 1. So this number is going to reduce to 1, and then 1 times anything is that thing. So let's simplify what we have so far. We can get rid of our 0 values, and we end up with this so far. So then we can say, well, let's figure out what that actually means. 2 to the 5th means 2 times itself 5 times. And similarly, you could say the same thing about 2 to the 3rd. That represents 2 times itself 3 times. So if you continue to simplify here, this is going to be 32 plus 8 plus 2 plus 1, which gives us 43. So hopefully you're starting to get the hang of this. Let's go ahead and make a tougher problem and take a look at how to work through a more difficult problem. So you can use decimals. You can use a decimal place and think about what that would mean. So we're going to start to the left of the decimal place just like we started before. On our previous problems, we started with an implied decimal place that wasn't actually there to the right of the number that we were dealing with, but it was implied that it was there. Here it's actually written in. You can see it. And so we're going to start to the left of the decimal place just like we would have started before. So we're going to say times 2 to the 0 times 2 to the 1 times 2 to the 2. What do we do over here? Well, we're going to say times 2 to the negative 1 times 2 to the negative 2 times 2 to the negative 3. Alright, and that may be a little confusing. I'm going to talk about what these things mean in just a moment. If you're a little unsure about your power rules, let's take a look at how to work this all out. So this is the same as before. This is going to end up being 0. This one right here is essentially 1 times 1. This over here is going to be 1 times 2 to the 2nd. That would be 4. Now the question becomes, what do we do with this business over here? Well, that becomes like 1 times 2 to the negative 1. What does it mean to have a negative power? Well, it means you take whatever that thing is and you put it in the denominator. So let me show you what it looks like. You're going to end up with this. So this one over here, 2 to the negative 1 power, means we take that 2 and we put it in the denominator. And let's go ahead and continue. This one over here, 2 to the negative 2 power, becomes 1 over 2 squared. And 2 to the negative 3 power becomes 1 over 2 to the 3rd. I can simplify these numbers over here. As we continue the problem, that would be 5, and I can start converting these into decimals. So 1/2 is 0.5, and this 1 over 2 squared becomes 1/4. This 1 over 2 to the 3rd power becomes 1/8. And of course we want to sum all of these up, and we end up with an answer of 5.875. So that's how you would approach a problem like this with binary to decimal example problem conversion. I'm going to go over all of the major ideas in a physics course throughout the year, so please take a look if you have any other questions about physics related material. I did promise that I was going to prove how this 0 power is equal to 1. So I want you to think about an example here. If we have something like this, that means 2 to the 4th, 2 multiplied by itself 4 times over 2 multiplied by itself twice. And what we can do is simplify this problem, and that would be like saying 2 to the 2nd. Well, if we were going to generalize that, we could say, therefore, we can follow this pattern with powers. If we have the same base here as over here, then effectively, you can do a subtraction of the powers and you end up with the correct answer. Okay, well, what if we solve this problem right here using that rule? Okay, well, this is a little more interesting if you think about it. What's going to happen is you're going to end up with 2 to the 2 minus 2 power. Well, 2 minus 2 is just 0. So this is going to be 2 to the 0. You might think, okay, that's a bit odd, but let's continue to think about this because we can recognize something with this fraction here, right? We can recognize that that reduces to 1 if we think about it, because anything divided by itself is 1. So what we're showing, therefore, is 1 is equal to this value of 2 to the 0. And in fact, this happens to be true for any real number that you work with. And that's how we know that a number to a power of 0 is equal to 1. So hopefully this has been helpful. If you have any comments down below, please let me know. And I hope you all have a great day. Take care.